So here we go. Let's take a look at this problem now. Force needed for a monolith. To build the pyramids in Egypt, it is believed that giant causeways were constructed to transport the building materials to the site. One such causeway is said to have been 3,000 feet long, with a slope of about 2.3%. How much force would be required to hold a 60-ton monolith on the causeway? So what we're going to do now is we're just going to try to figure out how that would work here. Now, at first glance, you might not think we have enough information, but we actually do. Now, notice here, this goes straight down, so then this here is actually going to be a right angle. And also, if I want to go perpendicular to this ground here, I'm going to draw this in there. Now, that's a right angle. Okay, and let's just try to find out what this angle is in here. Oops. Okay, that's the angle we want to find out now. So I know that this here is 2.3. And if I'm looking at this right triangle here, and I'm just going to draw it in there so you can see what I'm thinking here. So that would be my right triangle that I'm actually looking at first. So if I know that's 2.3 degrees, I can actually find this angle out now by just taking 90 minus that. And that's going to be 87.7 degrees. And that's what that angle is. And remember, on the other side, just by the way it's drawn, this here is 90 degrees. So that means this angle inside of here is 2.3 degrees. Okay, now I'm just going to redraw this and kind of zoom in on this triangle here, because this is the triangle I'm actually looking at. And the force that's going to hold it up is going to be this one here. That's what's going to keep it from falling and sliding all the way back down again. It's just holding it in place. Okay, so what we're going to do is we're just going to take a look at that and zoom in on it. So this is actually what we have here. Okay, and if I wanted to find out what this side was here, all I would have to think about is the sine of 2.3 degrees, and that's going to equal opposite over hypotenuse, which is 60 degrees. Not 60 degrees, 60 tons. Sorry for my bad language. So then if I wanted to solve this, my x would equal 60 times the sine of 2.3 degrees. And that would result in x equaling 2.4079 blah, blah, blah. And that tells me x is going to be 2.4 tons. So there's our answer for that problem. One of the biggest things to realize with this problem is that, remember, when I draw it, I'm creating it in such a way that this is actually going to be a right triangle too. So that tells me I can capitalize on that idea of using the sine of an angle being the opposite over hypotenuse. Makes it a very nice, easy, simple problem to do from there.